Today I want us to go over a little bit what we started in class with our art project and just kind of create that same picture just in our notes so you have. So on our next two pages, 17, 18, we're going to put sets of real numbers. And today's date, the 27th. All right, so going to page 17 and 18, I want us to draw that same thing that we painted today in class and kind of discuss that a little bit more. So draw your 4 circles. You might need to make this one a little bit larger than I did. So we said the very center represents our natural numbers. And natural numbers, just think of those as our counting numbers. So anything we count with, so 1, 2, 3, and so on. So they're always whole numbers, starting with 1, and then just keep going up from there. Now when we add a 0 to the mix, we get what we said was our whole numbers. So whole numbers are all of our natural numbers plus 0. Now when we add the opposites of all of those numbers, we get our integers. So now integers are all of the whole numbers plus the opposites. So -3, and that goes on forever to the left. -2, -1, 0, 1, 2, 3, and then so on. Now rational numbers. These are any number that can be written as a ratio, or really a fraction. So just to give you some examples of rational numbers, all of our fractions are rational numbers, all of our decimals, and even our repeating decimals are rational. If it repeats, it's still rational. So there's some examples in there for you. So we want to use these are the main ones we're going to use. We won't really look at irrational numbers too much. We're just going to look at rational numbers. We want to use these to classify numbers. So let's look at some examples. So if we look at some examples, let's just say classify each number. So if we look at 23, to classify that, well, figure out where it starts. So start in the center. Is 23 a natural number? Yes, it's greater than 1, or it's 1 or greater, and it's a whole number. So it's natural. So wherever you start, just keep going out into the circle, and it'll be all of those. So it starts at natural. So if we keep going out, it's also going to be a whole number, an integer, and a rational number. So all whole numbers, or all natural numbers, sorry, are going to end up being everything. Now if we look at the -7, so let's start at the center. It's not a natural number because we don't count with -7. It's not a whole number because it's not 0, 1, 2, 3, 4, so on. Our negative numbers don't start until integers. So it's an integer. And then just keep working outwards. It's also a rational number. And then all of these will always be real. So you can always add real to the mix, because real numbers just include all of the numbers we're looking at. And then one other one I want us to look at is, maybe let's look at 0. So again, let's start in the middle. It's not a natural number because we don't count with it. It is a whole number though, because 0 is included in our whole numbers. And then just keep working outwards. So if it's a whole number, it has to be everything else. So it's also an integer, and it's also rational. And then all of these will always be real. Now, even though we won't look at irrational numbers all that much, I do want us to write off to the side what an irrational number is. So just in some space you have, an irrational number is a number that cannot be written as a ratio. For example, pi is one. And then any decimal that repeats but does not have a pattern. So like that's why pi is 1, because 3.14, so on, so on, so on. There's no pattern, it just goes on forever. Another one are square roots that are not perfect squares. We can't take the square root of them, like square root of 5. There's no number times itself that will equal 5, so that's irrational. I'm going to put a circle around this so we know. And then let's go ahead and label these subsets of real numbers. Remember, all of these are real. This is on page 18. Subsets of real numbers. So if I were to give us, let's do one more example. Hopefully you have some room. -1/5. If we look at that, again, start at the center. It's not natural because we don't count with it. It's not a positive whole number. It's not a whole number because it's not 0 or a positive whole number. It's not an integer because it's not a negative or positive whole number. It's a rational number because it can be written as a fraction. It is a fraction. So it's rational. It can be positive or negative fractions or decimals. And then again, all of these are all real. And then if it's none of these, like pi is just irrational, but it's irrational and real. Whether it's rational or irrational, it's always real. So let's try to classify some of these. We'll do a couple more together, and then I want you to try some on your own. So let's have -17, 3.8, 2, pi, 9/10, and 3.789, with no pattern. It just goes on forever without a pattern. So, and actually let's add one more. Let's add -3. So looking at all of these numbers, let's just look at the first two together. -17, again looking at back to our circles. It's not a natural number because it's not positive. It's not a whole number because it's not positive or 0, but it is an integer. So if it's an integer, it's going to be everything else. Keep going out of the circle. So it'll be integer, rational, and they're all real. So integer, rational, and real. And then 3.8, well, it's not natural, it's not whole, it's not integer because it has some sort of decimal or fraction. But decimals can be written as fractions, so it is a rational number. And then that also makes it real. Go ahead and classify these 5 and see what you get. If we do these real quick, 2 ends up being all of them. So it's natural. I'm just going to use the abbreviations. It's whole. It's an integer. It's rational. And it's also real. Pi. Pi is not rational. Pi is one of the irrational numbers I want you to remember. So pi is irrational. But even though it's irrational, it's still real. 9/10. It's only rational and real. This one, since there's no pattern to this decimal, it just goes on forever without a pattern, it's irrational. But it's still real. And this last one, it's an integer, and then everything after that. So rational and real.